Hello everyone, my name is Hongda Li. I'm a junior student at the Lithium University. The paper I will be presenting today is titled Application of Lithium Batteries, Hydrogen Fuel Cells, and Solar Energy in Transportation Field. Now, let's talk about the introduction. The transportation sector relies on traditional fossil fuels. However, fuels such as gasoline and diesels release carbon dioxide, nitrogen oxide, and other pollutants into the atmosphere. The carbon dioxide emission per capita in 2020 reached 40.8 tons carbon dioxide per capita. In 2022, carbon dioxide emissions from the global transport sector grew by more than 250 million tons to nearly 8 billion tons of carbon dioxide, a 3% increase over 2021. For global warming, the transport sector contributes roughly 24% of the world's carbon dioxide emissions. To lessen the pollution and combat climate change, the energy transition in transportation sector is a key step towards achieving the Sustainable Development Goals. This research will introduce the current development status of energy transformation in the transport sectors from the three specific areas of lithium batteries, hydrogen fuel cells, and solar energy utilization. Understand the importance of these three areas in the transportation field and analyze their development advantages and existing limitations, which can pave the way for the establishment of a more sustainable, more efficient, and more environmentally friendly transport system. First, I will talk about the lithium batteries. The lithium batteries is a rechargeable batteries that can store and releases electrical energy by inserting and removing lithium ions between the positive and negative electrodes. In general, lithium batteries have made significant progress in energy density, output power, cycle life, charging rate, and monthly self-discharge rate in recent years. The improvements provide a foundation for technological advances in transportation, such as electrical vehicles. Table 1 shows specific values for these properties. Lithium batteries have several advantages, making them one of the most popular energy solutions in modern electronic devices and vehicles. First, lithium batteries possess a significant energy density. Second, lithium batteries can release electricity quickly and have high power output capacity. Third, the lithium battery can achieve a long cycle life. At the same time, as a rapid development of lithium batteries, there are still limitations to be solved as an energy storage device for storing electrical energy. First, lithium-ion batteries have limited cycle life and capacity decay problems. Secondly, some electrolyte components may decompose under high voltage and high temperature conditions, resulting in gases and sediments. Next, I will talk about the hydrogen fuel cells. A hydrogen fuel cell is an apparatus that generates electricity through the chemical reaction between hydrogen and oxygen. They belong to a class of renewable energy technologies that are environmentally friendly, efficient, and zero emission. Hydrogen fuel cells could achieve zero emissions, which is conducive to being a solution of energy transformation and promoting sustainable development of the environment. Hydrogen as a fuel has a high energy density. Hydrogen can be stored at a higher energy density than batteries and converted into electricity to power vehicles. The refueling time of the hydrogen fuel cell vehicle is faster than the charging time of electrical vehicles. The refueling process is similar to traditional car refueling and can be completed in just a few minutes. There are also some disadvantages like the additional challenges for system design and engineering, with higher requirements for material selections, thermal management, and system control. Under low temperature conditions, the hot expansion and cold contraction generated by frequent starting and stopping the conversion of automobiles can easily cause battery damage, which affects the fuel battery's life. Hydrogen is highly combustible and poses safety risks during storage and distribution. The last one is about the utilization of solar energy. In the realm of the transportation, the integration of the solar energy has progressively emerged as a significant trend in the energy transition. The application of solar energy in the transport sector is growing, contributing to reducing carbon dioxide emissions, improving energy efficiency, and promoting sustainable transportation. The reason why solar energy can become a key area of energy transformation in the transportation sector is inseparable from its own advantages. The first, solar energy is a zero emission form of energy. The second, solar energy can reduce the dependence of traditional energy resources and enhance the security of the energy supply. The third, solar energy is a widely distributed and renewable energy resources. But at the same time, there are still many drawbacks to the use of the solar energy. The first is about the variability and intermittence of solar energy. The second is about the energy density of solar energy is relatively low, especially compared to traditional fuels. So, in summary, lithium batteries, hydrogen fuel cells, and the usage of the solar energy play an important role in the energy transformation of the transportation system. They are environmentally friendly, efficient, and renewable, making a positive contribution to sustainable development. However, each energy transition technology has its own advantages and challenges and requires governments, business, and all sectors of society to work together to promote technological innovation and infrastructure development. There are the references for this presentation. Okay, that's all. Thank you for your listening.